All right, so this part is just kind of a review in terms of identifying and color coding different parts of that rational function. So you can look and see the non-canceling factors are pink in the denominator, the green, the blue, the yellow. Take a moment and make sure that you are able to identify all of those things. And let's take a look and see what that looks like on the graph. All right, so we have our discontinuity, infinite discontinuity, that's that vertical asymptote. We've got a hole, which is in the blue. And remember that the blue is the common factor, so you take that reduced form. So this is the reduced form that you plug in the x value of the hole to find the y value of the hole. And remember that that's going to give you an open circle. The yellow is the y-intercept here, and the green is the x-intercept. And so that's just what this saying down here says when the equation has a factor in the denominator that does not cancel out, we're going to get a vertical asymptote. A factor in the numerator that does not cancel out, then that's going to give us an x-intercept, also known as a 0. And if there is a common factor in the numerator and the denominator, that's going to give us that hole. And then when it's the equations in standard form, we just take a look at the quotient of the constants in the numerator and the denominator. All right. So that's all review. Now we're going to talk about more in this lesson about horizontal asymptotes. When do you have them and when do you not? So we've noticed that we've had some horizontal asymptotes, but right now we want to be able to look and see what kind of connections we can make. So here are some two functions, and it says, what do you notice about the degree of the numerator compared to the degree of the denominator for those two functions above? So if we were to take a look at the degree of the numerator, that would be a 1. Remember, it's a 1 if it's just the exponent of that, the highest exponent of the variable. So take a moment and tell me what you notice. And then also try to identify the equation of the horizontal asymptote. Okay, so hopefully you were able to see that the degree of the numerator is less than the degree of the denominator. And on each of those functions, they both have a horizontal asymptote of y equals 0. All right, so let's take a look at this example. We don't see a horizontal asymptote, but we do see some sort of slant asymptote, right? So we've got some sort of like diagonal type of line. And we are supposed to take a look at the degree of the numerator and compare that to the degree of the denominator. So we're going to compare the 2 and the 1, the 2 and the 1. Also try and see if you can figure out if there is a horizontal asymptote. All right, so if we look at this, the degree of the numerator is larger than, greater than the degree of the denominator. And it says, where does each function have a horizontal asymptote? Well, there isn't any. So this is none. There is no horizontal asymptote. All right, so now let's take a look at these two examples. Here we've got a horizontal asymptote here, and then we've also got one here. It says, what do you notice about the degree of the numerator and the degree of the denominator? So again, we're going to be comparing these. Again, just the degree part. All right, so hopefully you were able to determine that the degree of the numerator is the same as the degree of the denominator. So in this particular function h of x, where is the horizontal asymptote for the function? So we can look at that, and that's going to be at y equals 2. And then in this one, it looks like y is equal to -1. And so now they're asking us, well, what's the value of a over b if a is the leading coefficient of the numerator and b is the leading coefficient of the denominator? So basically what I'm doing is dividing 2 over 1. So I get y is equal to 2 over 1, and that's going to give me y is equal to 2. And again, we're going to do the same thing here. A is the leading coefficient of the numerator, and b is the leading coefficient of the denominator. So we have y is equal to negative 2 over 2, and that just simplifies to y equals negative 1. Okay. So based on all that we have seen, make a list of 3 rules that govern the existence and determination of horizontal asymptotes of a rational function. All right, so we're going to pause the video, think about those 3 rules, and answer the question. Okay, so the first idea is if the degree of the numerator is less than the degree of the denominator, then the horizontal asymptote, the equation of that is going to be y equals 0. Okay, it's going to be along the x-axis. Okay, as long as the degree of the numerator is less than the degree of the denominator, you're going to have y equals 0. Then the other situation we saw was if the degree of the numerator was greater than the degree of the denominator, then we noticed on the example, then there was no horizontal asymptote. Okay, that kind of goes right here with this example, right? There was no horizontal asymptote. And then the last condition was, hey, well, when we compared the degrees, they were equal to each other. They were the same. Okay, so when they were the same, what did we do to find that, that horizontal asymptote? Well, we just took the leading coefficient of the numerator and we divided it by the leading coefficient of the denominator. And that's what gave us the horizontal asymptote. So in your previous class, you might have studied this a little bit, but what I'm going to do is give you some acronyms to help determine those horizontal asymptotes. So this is where it might be a little bit familiar to you, but this right here is the technical verbiage and language of how to identify that, but these are just acronyms to help you remember that. BOBO. So if you're bigger on bottom, then your equation is y equals 0. So for example, if I have x over x squared. So, and again, we're talking about the degree. So if the degree is bigger on the bottom, then your horizontal asymptote is y equals 0. Number 2, botno. Bigger on top, that means there isn't any. There's no horizontal asymptote. So let's say that I have x cubed over x squared. Well, because the exponent is bigger on top, then that means there is no y or no horizontal asymptote. And remember that y equals 0 is the equation of a horizontal asymptote. And then lastly, the third one was when those exponents are the same. So it's called EATS DC. So exponents are the same. You divide the coefficients, right? So exponents are the same. We divide the coefficients. So y is going to be equal to the numerator leading coefficient divided by the denominator leading coefficient. All right, so those are just little acronyms to help you remember the idea behind those horizontal asymptotes. So now we get to, well, if it's not a horizontal asymptote, then it's possibly a slant asymptote. So let's make sure we understand when we have a slant asymptote, okay? This will always occur when the degree of the numerator is exactly 1 greater than the degree of the denominator. So if we have x cubed over x squared, then we are going to have a slant asymptote. If I have x to the 4th over x squared, that does not give me a slant asymptote. Okay, so again, it has to be exactly 1 greater than that. says, notice that the slant asymptotes are oblique lines, and that just simply means that they are not vertical or horizontal. So they have a slope and they have a y-intercept. So given below are the equations and the graphs of these three rational functions. We're going to use these graphs to answer the questions. So from the graph, what is the equation of the slant asymptote? Well, the first thing I wanted to do was identify that y-intercept, which is 4. And then to calculate according to the graph, let's calculate the slope. Well, I can kind of go up 1, 2, 3. So I'm going up 3 and I am running 3. So that gives me a slope of positive 1. Here is the y-intercept on this one. Let's calculate the slope. I'm going to go up 1 and to the right 2. So my slope in this case is 1/2. On this one, I've got my y-intercept at -1, but let's go ahead and figure out my slope here. Remember, you always rise first, whether you go up or down. So I'm going up 2, but I'm going to the left 3. So remember, it's rise over 1. So I've got positive 2 over -3, which just simply indicates a -2/3 slope. All right, so now it says from the graph, what's the equation? And so you can see that we've found our slope and our y-intercept across each of those three, the 1/2 and the -2/3. All right, so now it says synthetically divide the numerator. So this one was from the graphical perspective, and now we're going to go from the equation. All right, so we're going to take the numerator and divide it by the denominator. I've kind of already set this up. And then it says, what do you notice? All right, so let's just go ahead and synthetically divide. So I'm going to bring down that 1. I get 1 here. I've got 4 here, 4 and 6. And 6 is my remainder. And let's go ahead and synthetically divide the other ones. I've already kind of got them set up for that. So let's do 1, -1, -2, 2, and that gives me a 3. This is my remainder. And then -2, that's going to give me a 4. That's going to give me a -3. It's going to give me a 6 and a 9. And again, that's my remainder. All right, so it says, what do you notice? So I notice that my quotient has, if I were to divide this, my quotient is 1x plus 4, and my remainder is 6. This is, and again, remember your synthetic division, right? We're starting with this squared. So that means when we synthetically divide, this is an x, and then that's my remainder. And then the same thing with this equation, x squared divided by x. I'm going to start here. It's going to give me an x and then -3 in my remainder. Now, I don't know about you, but I was noticing that my quotient is 1x plus 4, which is the same as that slant asymptote. Okay. So now let's take a look at this. It's close, but if I take a look at 1x minus 2 and I'm trying to get it to be like that, it looks like I would have to divide that by 2. So in this case, I would have to divide my quotient by 2 in order to get my answer to look exactly like this. Okay, in order to look like the slant asymptote. And then let's see right here. In order for my my answer to look like this, it looks like I would have to divide by 3, right? So I would have to take this and I would have to divide by 3 in order to get it to match the equation of that slant asymptote. And so the question is kind of like, well, why do I have to divide by certain things? So I'm going to answer that question in just a moment. So here we go. The quotient is the ax plus b of the slant asymptote. So it's going to be the equation of the slant asymptote. The thing is, on number 2, we had to divide by 2, right? And here we had to divide by 3. Well, let's just take a look at that equation. Notice that I would have to take my final quotient and divide it by 2 because that was the leading coefficient of the denominator. Same thing here. I divide, but then I have to divide by 3 because it's the leading coefficient of the denominator. In the first one, I didn't have to do that because my leading coefficient was 1. Okay. So let's take a look. If I were to put that down and write it, it says, based on what we've just seen, explain how to find the equation of a slant asymptote. Okay, so let's see if you can write that down. All right, so now let's take a look. Well, the first thing you want to do is to perform synthetic division, and then you divide the quotient by the leading coefficient of the denominator. Okay, so that's what you want to be able to do. Or you can perform long division. So I have not gone over long division so far. All we've done is synthetic division. We can go over long division. It's a good, useful tool to know. Um, and that, and simply put, if you just performed long division, the process of long division will give you your slant asymptote equation. All right, so let's take a look at f of x right here. It says for each of the following functions, determine if there exists a slant asymptote or not. Give a reason for your answer. If it exists, determine the equation of it. So remember, we are comparing the degrees. All right. So the top is 3, the denominator is 1 for the degree. And so in this particular case, the slant asymptote does not exist because the degree of the numerator is 2 more than the degree of the denominator. And remember, if there is a slant asymptote, it has to be exactly 1 more. Exactly 1 more than. All right, so now let's take a look at this particular problem here. So we're going to synthetically divide, and I am dividing by the 0. When it comes to the remainder, I don't really care about the remainder. I care about the 1/2 plus 3. Okay, but then I am supposed to divide the quotient by the leading coefficient of the denominator. So I'm just dividing everything by 1, which just simply is going to give me y equals 1/2 x plus 3. Remember, we got to put y equals because we're looking for the equation of the line. Okay, so now let's take a look at this one. Well, the first thing I need to do is kind of multiply that out. So negative 2x times x, kind of FOIL out, distribute, combine like terms, reorder things. And so now we're ready to do synthetic division. Okay. We can also go over here and get ready to perform synthetic division. All right, so I'm going to ask you to see what you can come up with on P of x and also on G of x. All right, let's take a look and see what or how far you got. So synthetic division, I've got -2, a 1, and a 5. And remember, I get to disregard my remainder. I don't care about that. The last step is to divide the quotient by this leading coefficient. So if I were to divide each of these by -1, I am going to get 2x minus 1. And so that's going to be the equation of my slant asymptote. Now, if I look over here at g of x, again, I'm going to do synthetic division. I don't care about my remainder. This is 1x minus 7, but I have to divide by my leading coefficient. So dividing each by 2, I get 1/2 x minus 7 over 2, and that is going to be the equation of the line. So let's take a look on g of x. This is the graph, right? We're supposed to find the equations of the asymptotes of the graph h of x and then draw on the graph. So the easiest one to do is to find that vertical asymptote, which says to set that denominator equal to 0 and solve. So you can see that x equals -2. So I am going to go ahead and draw my vertical asymptote. Now the question is it going to be a slant or horizontal? Well, compare the degrees. 2 is exactly 1 more than the denominator. So that means I'm going to have a slant asymptote. So what we're going to do is we're going to do synthetic division. We're going to disregard the remainder. So that's going to give us -2x plus 2. But remember, I have to divide by 3. So now I need to divide by 3, and I get -2/3 x plus 2/3. So what I'm going to do is start on my y-intercept. I've got that right here. And then I'm going to go up 2, 1, 2, and then over 3. So 1, 2, over 3. Nope, I didn't go over 3. I went over 2. So there we go. So let me go back here. 1, 1, 2, 1, 2, 1, 2, 3. 1, 2, 1, 2, 3. So right about there. So now let's go down 2 units and then over 3. Down 2 units over 3. And so now what you're doing is just sketching the line through those points. And then what you normally do is make that dotted a little bit, if you can. And then you write the equation right here. Y is equal to negative 2/3 x plus 2/3. And that's the equation of the slant asymptote. So one of the things when it comes to asymptotes, I'm going to give you kind of like this overreaching idea of like how to tell what kind of asymptotes you have. So you will end up with possibly a vertical asymptote, a horizontal asymptote, or a slant. So these horizontal or slant, you cannot be both. You cannot have a horizontal and a slant. It's either or. With vertical, it could be and. Okay, so I can definitely have a vertical and a horizontal, or a vertical and a slant. All right, so I'm going to put this. Just do and or. But you cannot be horizontal and slant. It's or. These are or. Okay, can only be one or the other. So again, just to re-clarify, vertical is non-canceling factor in the denominator. The horizontal was bigger on bottom, it's y equals 0, or exponents are the same, then you divide those coefficients. If the degree of the numerator is exactly 1 more than the degree of the denominator, then that's when you're going to have the slant, and then that's when you're going to synthetically divide and get that equation of the line.